So now to calculate I of h comma h by 2, we have I2 plus 1 upon 3 I2 minus I1, and that gave us 0.6932. Okay, so we made use of, it was I1, I2 and I3, and regarding I1 it was h, regarding I2 it was h by 2, and regarding I3 it was h by 4. So integration with respect to h and h by 2, that is I1 and I2, it gave us this. Similarly, integration with respect to h by 2 comma h by 4, we have I3 plus 1 upon 3 I3 minus I2, which is equal to 0.6931. Similarly, I of h comma h by 2 comma h by 4, which is equal to I5 plus 1 upon 3 I5 minus I4, which is equal to 0.6931. So now you can solve this type of examples, and let's see a further point, which is nothing but Gauss-Legendre integration method. So in this method, let us consider weight of function, that is w of x, to be 1. Okay, and what we know that the limit of integration should be from -1 to 1 always in terms of Gauss-Legendre integration method. Okay, so this is fixed, that is weight is always 1, and then the limits are always fixed, that is it's from -1 to 1. So integration -1 to 1 f of x dx is given by summation k running from 0 to m lambda k f of x. Okay, so this is the integration value. Now we will consider few cases regarding this value of m. So now, as xk and lambda k are the unknowns, so I, which is equal to integration -1 to 1 for m equals to 0, will change to f of x dx equals to, now if m equals to 0, so there is just one term, that is lambda 0 into f of x 0. Okay, so this formula what you got by just substituting value of m as 0, this is known as one point formula. Now if you observe in this formula, we have lambda naught and x naught. These are the two unknowns, so we need to find the values of this unknowns. Okay, so now this formula is applicable only for the polynomials of degree which is less than or equal to 1. So maximum degree is 1. So we are left with f of x as either degree 0, that is 1, or x. Okay, so these are the possible polynomials for this kind of condition, that is one point formula. Now if we consider f of x equals to 1, so let us take one case. So then we'll get -1 to 1 f of x, that is 1 dx, equals to, now lambda naught f of x naught, so we'll just get lambda naught. Now so this will become x from -1 to 1, which is equal to lambda naught. So lambda naught will be equal to 2. Okay, so this is the value of lambda naught. Now if f of x equals to, similarly if f of x is equal to x, then this will change to -1 to 1 x dx, which is equal to lambda naught x naught, which is equal to x square upon 2, that's the integration of x So from minus 1 to 1, which is equal to lambda naught x naught. So after solving this, you will get 1 by 2 common, then 1. So now x square, so 1 minus 1 square is 1 again, so this will become 0, which is equal to lambda naught x naught. So from this you got value of lambda naught x naught to be 0. And since this lambda naught is not equal to 0, so we can see that x naught is equal to 0. Okay, so after substituting the values of lambda naught and x naught in this equation or in this 1-point formula, you'll finally get it as I equals to integral minus 1 to 1 f of x dx equals to 2 into f of 0. Okay. Similarly, if you substitute value of m as 1, then you will get 2-point formula. So we'll conclude or we'll follow the same process, that is I equals to minus 1 to 1 f of x dx, which is equal to summation lambda k f of xk, where k goes from 0 to n, and in this case it goes from 0 to 2. So this can be simplified as lambda naught f of x naught plus lambda 1 f of x1. Now here again we got 4 unknowns, that is lambda naught, x naught, lambda 1 and x1. So again we need to find the values of all this. So let us consider. So as in the first case where we had a 1-point formula, there was restriction on the degree of polynomial, that it was of maximum degree 1. Now in case of 2-point formula, the maximum degree of the polynomial is 3. So we have polynomials which are less than or equal to 3. So possible values are 1, x, x square and x cube. Okay, so we'll consider each one by one. So if f of x equals to 1, then integral minus 1 to 1 f of x dx, which is nothing but integral minus 1 to 1 dx equals to lambda naught plus lambda 1. So this will give you lambda naught plus lambda 1 equals to integration of this is x from minus 1 to 1, so this will give you 2. Again the value is 2. So this is one equation regarding lambda naught and lambda 1. Now another case is if f of x equals to 2, if f of x equals to x, then this integration minus 1 to 1 f of x dx will be minus 1 to 1 x dx, which is equal to lambda naught x naught plus lambda 1 x1. Okay, so now after this what we will get is integration x square to minus 1 to 1, which is equal to lambda naught x naught plus lambda 1 x1. So as in previous case its value was 0, so we got lambda naught x naught plus lambda 1 x1, which is equal to 0. That's our second equation. Now the third case, if f of x equals to x square. So again following the same procedure, f of x dx equals to integral minus 1 to 1 x square dx, which is equal to lambda naught x naught square plus lambda 1 x1 square. So this will give you x cubed by 3 minus 1 to 1 dx, dx. So it is lambda naught x naught square plus lambda 1 x1 square. So solving this, you will get values of lambda naught x naught square plus lambda 1 x1 square as 2 upon 3. the third one. Now the last case, that is for x cube. So if f of x equals to x cube, then integral minus 1 to 1 x cube dx will be equal to lambda naught x naught cube plus lambda 1 x1 cube. So this is x raised to 4 by 4 from minus 1 to 1, lambda naught x naught cube plus lambda 1 x1 cube. So this will lead us to lambda naught x naught cube plus lambda 1 x1 cube equals to 0. So that's the fourth equation. So now next what we are going to do is we will solve this equation to get the values. So first we need to multiply equation 2 by x naught square, and then we need to subtract equation 4 from whatever we get. So this will be lambda 1 x1 into x naught square minus x1 square, which is equal to 0. Now this is a square minus b square, so we can directly write it as x naught plus x1 into x naught minus x1, which is equal to 0. Now if we consider lambda 1 to be 0, then what we will get is lambda naught equals to 2, which we had derived from equation 1, because equation 1 was lambda naught plus lambda 1 equals to 2. So after substituting lambda 1 as 0, we will get lambda naught as 2 from equation 1. Okay. So now from equation 2, what we get is, what is the equation 2? It is lambda naught x1, lambda naught x naught plus lambda 1 x1 equals to 0. This is the equation 2. So after substituting this, that is value of lambda naught is 2, x naught plus lambda 1 is 0, so 0 into x1 equals to 0. So 2x naught equals to 0, so this will definitely lead us to x naught equals to 0. Now we got the value of lambda 1 to be 0, x naught to be 0. Now we got the values of lambda 1 and x naught as 0. Now as lambda 1 is not equal to 0, similarly we can see that x1 is not equal to 0, which leads us to x naught is not equal to x1, because if x naught is equal to x1, then from equation 2, that is this is the equation. So from this what we will get, lambda naught x naught plus lambda 1 x1 equals to 0. That was the equation, and if these two are equal, then lambda naught plus lambda 1 into x1 equals to 0. Now this lambda naught and lambda 1, we have values as 2 and 0 respectively, so we can have 2x1 equals to 0, and from this we'll get x1 equals to 0, which is a contradiction to the fact that x1 is not equal to 0. So this is not possible. Now if x1 is equal to 0, as if we consider this x1 is equal to 0, then what will happen? So we have from equation 2 lambda naught x naught plus lambda 1 x1 equals to 0. So that was the equation 2. So from this, if x1 is 0, then this term gets eliminated. So we'll be left with lambda naught x naught, which is equal to 0. So that will give us lambda naught equals to 0 or x naught equals to 0. And we know that lambda naught value was 2, which we had derived from equation 1. So this is not possible. So only possible cases, x naught equals to 0, and this happens. So both the cases it is not possible, because if we substitute, then I value, integration value becomes 1. So now from equation 2, what we can see, this will lead us to x0 plus x1, which is equal to 0, and this will give you x0 equals to minus x1. And from equation 2, we can substitute this value, so you'll get lambda naught minus lambda 1 into x0 equals to 0, which will give us lambda naught minus lambda 1 equals to 0, because x0 is not equal to 0. So we'll get lambda naught equal. So lambda naught is equal to lambda 1, and then from equation 1 we got it as value is 1. So similarly, substituting the values in equation 3, we get x0 square plus x1 square equals to 2 upon 3. Now as x0 equals to x1, so we can directly write x0 square plus x0 square equals to 2 upon 3. So x0 square equals to plus or 1 upon 3. So x0 will be plus or minus 1 upon root 3. So these are the values of x0. So x0 will be 1 upon root 3, plus or minus 1 upon root 3, or x1 will be plus or minus 1 upon root 3. So our final integration, that is I, will be minus 1 to 1 f of x dx, which is equal to f of 1 upon root 3 plus f of minus 1 upon root 3. So this is regarding 2-point formula. Now we need to consider the error. We need to consider error regarding 1-point formula and 2-point formula. So for n equals to 0, error is nothing but c upon n plus 1 factorial f raised to n plus 1 eta minus 1 is eta is less than 1. So this, as n equals to 0, so we have degree of polynomials up to 1. So we can substitute value of n, that is the degree, as 1. So you will get c upon 2 f double dash of eta. Now what is this c? C is nothing but integration minus 1 to 1 x square dx minus summation k running from 0 to, now m is 0, so then integral from 0 to 0, we can say lambda k xk square. So this will give you x cubed by 3 from minus 1 to 1 minus lambda naught x naught square. So this is nothing but 2 upon 3 minus lambda naught value. In the case of n equals to 0, we have found it as 2, so 2 into x naught, which is 0, so 0, so value of this is 2 upon 3. So after substituting the value of c in this error formula, so error is nothing but 2 upon 3 into 2 into f double dash of eta, which is 1 upon 3 f double dash of eta. Okay, so this is the error for n equals to 0. Now if n equals to 1, then I equals to minus 1 to 1 f of x dx, which is equal to summation k running from 0 to 1 f of x dx, sorry, f of xk into lambda k, which is equal to f of 1 upon root 3 plus f of minus 1 upon root 3. We had calculated in the previous part. So C is nothing but integral minus 1 to 1 x raised to 4 dx minus summation k running from 0 to 1 lambda k xk raised to 4. So this integration will be x raised to 5 upon 5 from minus 1 to 1. And after solving this, I get 1 by n plus 1 by n, which is equal to 8 upon 45. So after substituting the value of error in C, we will get error as 1 upon 135 f double dash of theta. Similarly, for n equals to 2, I can be written as integral minus 1 to 1 f of x dx, which is equal to summation k running from 0 to 2 lambda k f of x. That was our initial 3-point formula. So now using 3-point formula over here, you will get lambda naught